Today is the 9th of October 2024, and this will be our second video on completing the squares. Okay, we started looking at completing the squares in our last video. Okay, please go and watch it. It will help you a lot. Recap. Watch last video for recap. Okay. Example. So you have x minus 3 all squared. This on its own, anyone in the foundation class can expand this. This will give you x minus 3, one bracket, x minus 3, the other 3, second bracket. So you can solve it and you use your x, multiply by everything in the bracket. So you multiply s by x, x by minus 3, and then minus 3 by x, minus 3 by minus 3. If I say by, it means multiply, which will give you x squared minus 3x minus 3x plus 9. So this x squared, x minus 3 all squared, okay, is x squared minus 6x plus 9. Okay. Now, if you want to complete the square, okay, to perfect squares, okay, now you want to get rid of this 9, because this 9, 3 square is what? 9. So if I subtract both, this is adding. So if I subtract both sides by 9, I'm going to get x minus 3 all squared minus 9. So x minus 3 is now a square, and then 3 squared, which is 9, is also a squared. And this will be equal to, we've gotten rid of this 9, so this will become x squared minus 6. So in the last video, I said to you, assuming you are proving something and you know this principle, and you get to x squared minus 6, okay, you can interchange it with x minus 3 all squared minus 9, or assuming you are solving a question and you get x minus 3 all squared minus 9, instead of stopping there, you can interchange it with this, assuming there is plus 6 somewhere, so that you can get rid of that. Okay, so it's a good thing to learn, and that's why it's for higher students. Okay, so this is what we basically did, but you can do some, you can it's not all the equations that you got. Some of them you can complete them as perfect squares like this. Okay, some of these they might ask you to prove like minus 10. So instead of subtracting minus 9, you end up subtracting minus 10. Okay, and then you manipulate it till you get what you are given. Okay. Now, I also said to you that from here, you can get to this point straight away. Okay. So uh, uh, half of 6 is minus 6 is minus 3. So x minus 3 all squared. And then minus 3 all minus 3 all squared is 9. So minus 9. I hope you got what I said. Equals x squared minus 6x. So instead of going through all this process, you could guess if you see a question like that, you can use that to complete the squares and then substitute it in whatever you are supposed to show or whatever you are supposed to solve. Today I'll start, we are going to do circumference. So R equals of a circle. So R equals that is the radius is 7 centimeters. Okay, we are going to leave the answer in pi. The circumference formula is 2 pi r. Okay, so now 2 pi times r, which is 7. So 2 times 7 is 14 pi, so centimeters. Circumference is a length, so there is centimeters because our radius is in centimeters. Another one, r equals 9 meters. Remember your unit. So 2 pi r, which is 2 times 9, 18 pi, and then meters. So 18 pi in meters because the radius is in meters. So today it will be our second completing the squares. Okay, so as I showed you in the recap, okay, completing the square 2, writing it in the form ax squared plus bx plus c. Okay, so half the coefficient of x, so that is a b, half of b. Take care in correcting the constant term. So example, rearrange x squared minus 1 all squared plus 9, okay, equals x squared minus 2x plus 10. So they said we should rearrange this. Okay, so first, x minus 1 all squared will be equal to x minus 1, x minus 1. Okay, so now we have x squared minus x plus 1. And then we have x squared minus 2x plus 1. So x minus 1 all squared will be equal to x squared minus 2x plus 1. Okay, now I'm supposed to prove I should rearrange such that x squared minus 1 plus 9 will be equal to x squared minus 2x plus 10. So if you look at this step carefully, okay, if I add 9, okay, that will become the 10 I want to prove this side. So I'll add 9 to both sides. So now I have x minus 1 all squared. Add 9, and then that will give me x squared minus 2x plus 1 at 9, which will become 10. So I've shown it. X squared minus 1 all squared plus 9 is the same as x squared minus 2x plus 10. So sometimes you might not get ax squared plus bx, but you might get something else here, because assuming I'm solving, I can do the manipulations that in place of x squared minus 2x plus 10, I can write x minus 1 all squared plus 9. Okay, so these are some of the things you might have to learn how to do, and the more you do it, the easier it becomes. So if you look at this, x minus 1 all squared and 9 are squares there. So I've completed the square. So this all squared and 9 is 3 squared. So I've completed it. But here, they didn't ask me. They gave me that I should show. So I have manipulated my completing of the squares to show what the question is asking me to show. Okay, I hope you understand. Let's quickly look at another example. Show that x plus 5 all squared minus 10. Here, minus 10, this part here is not like completing the squares, but we are going to use that method. Okay, because they said we should show that this equals this. So we are going to use the method of completing the squares to show that this equals this. Okay. Here again, if you look at it carefully, if it was 9, that would be 3 squared. But this, if you square root this, you are not going to get a whole number, so it's not really perfect squares. But we are asked to show. So again, maybe this will be an A part of a question, and then from there you are supposed to deduce something, which you would need this step to substitute in what you are deducing to get your answer, and that is also in higher maths. But you need to know if you are doing, and this is so in case you meet it somewhere, you can apply this principle to solve your question. So let's start with it. So we'll start with this part here. Okay, so x plus 5 all squared. So x plus 5 all squared, we will write it as x plus 5, x plus 5. I've done similar things with you, but not in this way. So first, you look at what you've been given and work towards it. Okay, or you can work towards it in reverse. So this here, x plus 5 all squared, will give us x squared plus 5x plus 5x plus 25. So you get x plus 5 all squared equals equals x squared plus 10x plus 25. Okay. Now, if you look at what you are showing, there is a minus 10 here. So, if I minus 10 on both sides, okay, then I have x plus 5 all squared here, minus 10. And then I have x squared plus 10x plus 25 minus 10. Okay. Now, I was going to show you something else, but I'll leave it for another group. So now we have x for another time. So now I have x plus 5 all squared, okay, minus 10, okay, equals x squared plus 10x plus 15, because there was a 25 here. So if I'm subtracting 10 from both sides to get the equation, so I have to subtract the 10 from the 25. So I have x plus 5 all squared minus 10 equals x squared plus 10x plus 15. Okay. Now, as I explained, 10 is not a square, but we've used that principle to solve this equation, okay, which makes maths beautiful, because as I said, nothing will ever go to waste. Life is about solving questions for yourself personally and for your home, okay, and maybe in future for other people as well. But if one of the things about school is, as you solve these questions, you start getting the intuition. Okay, I have this problem, how do I solve it, how do I go about it? Okay, now 10 is not a square here, but we have answered the question. Okay, we have solved the question we've been asked. So again, it might be that this question might be thrown maybe in an A part, and then we'll use this to go and do another part. Okay, so maybe instead of this, we'll substitute this to make our deductions easier. Okay, so this is what I have for you today. Thank you so much for coming along with me, and I'll see you in the next